So just continuing with the lunar module, what you see on the left is a cutaway artwork of the lunar module that shows both halves of the lunar module. The top portion is called the ascent stage, and it contains the crew cabin and the controls and displays, the environmental control system, the cabin oxygen supply, and so forth, as well as the all-important ascent rocket engine that would be used to get the astronauts off the moon and back into lunar orbit. You can also see around the perimeter of the lunar module 4 clusters of small maneuvering engines. These, by the way, are also found on the side of the service module, which I forgot to mention. And these are used to adjust the craft's orientation in space. They're called the reaction control system. The bottom portion, and in the ascent stage, you also see at the top the docking receptacle called the drogue, and that opens into a very small tunnel that leads into the main cabin from the ceiling. And the front hatch is the square hatch that the astronauts would enter and exit when they walked on the moon. The bottom half of the lunar module is called the descent stage, obviously because it contains the descent rocket that they would use to get from lunar orbit down onto the surface of the moon. And it was the first rocket engine that had a throttle. The astronauts could actually adjust the amount of thrust that it put out in order to control their descent, just like you were flying a helicopter, only in this case you're using the thrust of the rocket engine to slow you down. The descent stage also contains the 4 landing legs that you see there. The front leg has the ladder that the astronauts would climb down. At the top of the ladder is a rectangular platform with handrails on it that was called the porch, the front porch, by the astronauts. And also, you can't really see it in this cutaway, but there are several storage compartments for scientific experiments and tools that the astronauts would use on the surface. On the right, you see an actual lunar module being checked out at the Space Center in Florida, at the Kennedy Space Center, and you can see the top of the ascent stage. The skin of the ascent stage is basically very thin metal panels, sheets of metal that are bolted on, and the crew cabin that's within that is also very thin metal, almost like a balloon made out of metal. Again, because the lunar module had to be so lightweight as possible. You can also see one of the main communication antennas at the upper left of the ascent stage sticking up. And of course you can also see those small maneuvering thrusters that are covered with white or cream-colored cones covering the actual nozzles. Those would be removed before the flight. The bottom half, the descent stage, is covered in gold or orange-colored kapton, which is a metallized plastic, an aluminized plastic, very thin, and it was basically the descent stage had no walls, really. It just had these kapton sheets that were attached to the frame and basically controlled the temperature of the fuel tanks and oxidizer tanks inside from getting too hot or too cold. So these sheets of aluminized kapton were meant to provide thermal control. And you can see that they haven't put the legs on yet, but you can see the support struts protruding from the side of the ascent stage where the legs will eventually be attached. So that is the LEM, a very strange looking critter indeed, but that is because of 2 things: the need to save weight and the fact that it would not fly in an atmosphere. It would only fly in the vacuum of space. For that reason, the lunar module has been called the first true spaceship. Well, the Apollo spacecraft, of course, could not get to the moon without the giant Saturn V moon rocket. And what you see on the left is an actual Saturn V on its launch pad and the accompanying service tower. And at the bottom of the page, you can see an artwork that compares the Saturn V with previous launch vehicles. And just look at how much bigger the Saturn V is than even the Saturn 1B, which would be used to launch the first Earth orbit mission of Apollo, the test flight. But my God, it's so much bigger than the Gemini Titan, you can see. And then next to that, the Atlas Agena, the Atlas Mercury, the Mercury Redstone, and of course the V2 looks like basically a firecracker next to the Saturn V. It was actually 363 feet tall from the base of the first stage engines to the top of the escape rocket on top of the Apollo spacecraft. It is still the largest rocket ever successfully flown, 58 feet taller than the Statue of Liberty. It was an incredibly complex vehicle. You can imagine all of those engines in the three stages of the rocket, all the parts that went into that. It even had its own guidance system that would steer it during the launch. That came in handy on Apollo 12 when the spacecraft got struck by lightning, but we'll find out about that in a later week. You know, there were literally 1 million parts, or a couple of million parts, in the Saturn V. So the quality control issues for building the moon rocket were just staggering. It was just an incredible undertaking. And just as complex was the actual launch pad itself, with all of the machinery to pump fuel and oxidizer into the Saturn, to monitor the health of the vehicle and transmit that data to the Launch Control Center. And then it was all resting on an actual crawler, a transport vehicle like a gigantic tractor that transported it from the giant vehicle assembly building to the launch pad. Now, the one thing that really saved Apollo from meeting the end of the decade deadline of getting to the moon was an idea by a NASA manager named George Miller, who was at NASA headquarters. He was the head of the Apollo, he was the head of the manned spaceflight portion of NASA, and he figured out that you could not afford to have test flights for each stage separately. That was the way von Braun's people were used to doing things. You know, you'd launch the first stage with just a nose cone on it, and then you'd launch the first stage and the second stage, and then you'd put the 3 stages together, and then finally you'd put a spacecraft on it. Well, he realized that not only was that going to take too much time, but it really didn't reduce the risk of failure very much. And in fact, it used up precious hardware in those test flights. So he actually decreed that the Saturn V would be tested all at once. They called it all-up testing. And that decision turned out to be just a key decision in saving the schedule for getting to the moon by the end of the decade. Well, in the next segment, we'll find out how the Saturn V did on its first test flights.